We're starting a new unit today, and we're going to be focusing on identifying linear features of linear functions. So there's all kinds of features we're going to talk about. We're going to start with identifying the basic features on your graph. So hopefully today in class, you added your Unit 1-4 tab, and I want these two facing each other. So hopefully you did that in class today. If you did not, please take a moment and do it now. Okay, so we're going to start with linear functions. We're going to review what we know about linear functions, and we're going to add in anything that we don't know. Okay, so first of all, we know that the graph of a linear function looks like a straight line. So, straight line, no curves, no bends, nothing fancy, just a straight line. Okay, the parent function is y equals x. Now, we're going to learn about function notation, so we're going to write this down. It may not make as much sense to you for a little while, but that's okay. We're going to write, so it's f of x equals x. And we're going to learn about function notation tomorrow, but I want you to go ahead and write it down. We're also going to learn about standard form later on, not this test, but the next test will be testing over standard form. And this is on your formula chart. It's ax plus by equals c. And we'll talk about this again later. So these two, don't be so concerned about right now. This one we'll learn about tomorrow. Now, slope-intercept form we should be very familiar with. Y equals mx plus b. That's our slope. That's our y-intercept. Okay? And the last form, again, these three are on your formula chart. That's point-slope form, which is y minus y1 equals m times x minus x1. And that's my slope. And I have a point at x1, y1. Okay? So these are this is stuff that we have all learned. All right? So now, and some of this you've learned in other classes, but this is stuff that you have to know for mine. Okay? The next thing we know is we know that a graph is linear from looking at a table because all rows share, that says that's an A, share the same rate of change. So that's our delta y over delta x. Now, this does not mean, this doesn't mean we check the first couple and they're right, or we check one pair. For a table to represent a linear function, every single row in the table has to have the same rate of change. So it can't just be one row or the first row. It has to be, you have to check every single one. So you have to, like we would have to do delta y over delta x for every single pair in this table. And it would have to be the same rate of change all the time. All right? And I can tell from a system because if I see those keywords, I see those linear or slope keywords like per, each, for one, every. And those are those words that tell me that I have, that should be a capital I, a constant rate. Okay, so those are those linear slope keywords. So when I'm looking at a situation and I see those linear slope, those linear keywords like per, each, for one, every, those tell me I have a constant rate. That constant rate means I'm linear. Okay, so now we're gonna talk about our key features of our graph. And again, most of this is stuff you know. This should be pretty much mostly review. But we're gonna add one thing that we kind of briefly touched on last unit, but we're gonna actually talk about it a little bit more. Okay, so I want you to take a moment and I want you to get these points drawn. I want you to get this table written down, and then we're going to draw the graph of it. If you want to go ahead and do that while you're paused, that's fine. I'm going to do it when we get back. Okay, so you've written this table down. Some of you may have graphed it, but I'm going to go ahead and plot these points. So I have a point at -6, -6, so 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 6, -3. Y'all, you know I struggle with graphing, and so I'm kind of paranoid right now. Then I have one at -4, 0. I have one at -2, positive 3. I have one at 0, 6. And I have one at 2, 9. Now I'm going to connect these points with a straight edge. Again, you can use the edge of your badge, You can use a ruler, whatever makes you happy, but we don't just draw some jankety line. We want to draw a good line. I mean, pretend that I actually do that through all the points, but you understand what I'm trying to say. Okay, so now when I'm trying to identify key features, the key features that we have, there are four key features we're looking for in a graph, okay? So the first key feature is the y-intercept, okay? So we're going to say y-int because I'm too lazy to write intercept. Okay, now our y-intercept is where the line crosses the y-axis, and it's also the row that starts with 0. So my y-intercept is 0, 6. And I'm going to write this as an ordered pair because remember, they might be asking me about the x-intercept, which is written with the number first. So I want to be writing them as ordered pairs because some of you guys got caught on the last test because you didn't write them as ordered pairs. So I don't want y'all to get caught, okay? The next easiest thing to identify is the x-intercept. The x-intercept is where the line crosses the x-axis. Okay? Now, they also call this a 0. Okay? And you know I'm always trying to think of silly ways to think of this, and the only thing I can think of to help you remember that what a 0 looks like in an ordered pair, it looks like this. And here's how I think about that. I am a Deal. My last name is Deal. My husband's last name is Deal. My daughter's last name is Deal. My father-in-law's last name is Deal. My sister-in-law's last name is Deal. We are all Deals because our last name is Deal. This is a 0 because its last name is 0. So if the last number in the ordered pair is 0, it's your x-intercept or 0. If the first number is 0, then it's your y-intercept. Again, it's all I got. Okay, so that's what I'm going with. Okay, so my x-intercept is -4, 0 because his last name is 0. Okay, so that's 2 of the key features. Actually, this is 2. X-intercept and 0 are actually 2 of the key features. So the last key feature that we're looking for is our slope. Okay, so the slope is my rise over run. So I'm going to rise 1, 2, 3, 4, 5, 6. I'm going to rise 6. I'm going to run 4, 6 over 4, which reduces to 3 over 2. Now, if you put 6 over 4, it's wrong. If you put 3 over 2, it's right. I know that sounds crazy. And if you put 1.5, it's right too. All of those are correct. Okay, every single one of those. All right, except this one is less correct because it's not reduced. I'm okay with you writing it as an improper fraction. I'm okay with you writing it as a decimal. I'm not okay with you leaving it unsimplified. Okay, so the last thing that you might need to do with this is write an equation. Well, the equation of this line is y equals m, which is 3/2, or 1.5 x, plus my y-intercept, which is 6. And that's my equation. Those are my key features of my linear functions. The next video you watch is going to be a whole bunch of examples of key features. I expect you to watch them and I expect you to follow along.